In this video, we are going to discuss about phase shift oscillator. Since in the feedback network, we have using this is a feedback network. So in this, we are using R and C. Okay. So let me write this as CR. Okay. So 3 RC network. So each network will provide 60-degree phase shift. Totally, it is providing 180-degree phase shift. Okay. And if we see in the op-amp stage, since the input is connected to the inverting terminal, this also produces a 180-degree phase shift. So according to the Bagasan criteria, these two, this op-amp and this feedback terminal will provide totally a 360-degree phase shift. So 360-degree, I can write it as 0-degree phase shift. And in order to have an oscillation, since we are producing a sine wave at the output, the condition is Bagasan criteria, magnitude of A beta is equal to 1. Here beta is nothing but Vf divided by V naught, and so here A is equal to V naught divided by Va. Okay. So this term I'm going to write it here, since I need to find the value of V naught, right? So this V out. Okay. CR, and I'm going to write this value as this is Vf. Okay. And here I'm going to apply a nodal voltage method. Okay. So this node I'm taking it as V1, and this node I'm taking it as V2, and the current flowing to this terminal, this direction. Okay. So I can write this I1, and this one is I2, and this one is I3. Okay. So what is my V1 value? I can write V1 is equal to I3 into XC, plus I3 into R, right? So the I3 into R is nothing but Vf. Okay. And I3. So since I am writing, I'm writing Vf is equal to I3 into R. Okay. So I can write I3 is equal to Vf by R, right? So I can write this one is equal to, and we know that this according to the Kirchhoff's current law, at this node at V2, I can write I1, the incoming current I1 is equal to, so I can write this is I1 minus I2, right? So this current I1 minus I2, outgoing current, plus I2, right? So this I1 minus I2, I can write it as V2 divided by R, plus I2. Okay. Similar way at KCL at V1. So at V1, I can write, applying KCL at V1, I can write I2. I2 current is equal to I2 minus I3 plus I3, right? So this current is I2 minus I3. So which is nothing but I2 minus I3 is V1 divided by R plus I3. Okay. So how to write I3? I3 is nothing but so from this I can write I3 is equal to Vf divided by R. Okay. So I can write this I2 is equal to V1 divided by R plus Vf divided by R. This is my I2. So I can substitute it here. V2 divided by R plus V1 divided by R plus Vf divided by R. This is my I1. Okay. So how to write I2? So I2 current I can write it as I2 is equal to V2 minus V1, V2 minus V1 divided by XC. So I can write V2 minus I2 XC minus V2 is equal to minus V1. Okay. So what is my I2? So here I need to find the value of since I have find the value of V1, I can substitute it here. I can substitute this first equation in the second equation. Okay. So we can write I2 XC minus V2 is equal to minus of Vf XC divided by R plus 1. So here also I can substitute the value of V1. So what is V1? V1 is equal to if I take 1 by R, I can write V1 is equal to Vf if I take common XC by R plus 1 plus Vf by R. So this I can write it as Vf if I take it common XC by R square plus 1 divided by R plus 1 divided by R. So this I can write it as I2 is equal to Vf XC by R square plus 2 by R. This is my I2. So now I can write this is my I2, right? So now you substitute this is my third equation, this is my fourth equation. Okay. So you substitute 4 in 3. So now I can write V2. What is V2? V2 is equal to I2 XC plus Vf into XC by R plus 1. Okay. So you substitute this fourth equation in this equation. Okay. So Vf into XC by R square plus 2 by R into XC plus Vf into Xc by R plus 1. So this I can write it as Vf into Xc square R square plus 2Xc by R plus Xc by R plus 1. This is my V2. Okay. So I need to find what is my V out. Okay. So what is V out from the diagram? From the diagram I can write V out. V out minus V2 is equal to I1 into Xc. Okay. So what is my I1? So I can write V out. V out is equal to I1 Xc plus V2. Am I right? So I have found my V2 value as this one. So V out is equal to I1 Xc plus V2. I1 Xc plus V2. Okay. So what is my I1? I1 is V2 by R, V2 plus V1 divided by R, V2 plus V1 divided by R plus Vf by R, V2 plus V1 plus Vf divided by R into Xc plus V2. V2 is equal to Vf into Xc square plus 3Xc by R square plus 1 plus V1. So what is V1? V1 is equal to Vf Xc by R plus 1. Okay. V1 is equal to Vf into Xc by R plus 1 plus Vf divided by R into Xc plus P2. So I can take Vf common, right? So if I take Vf common, so I can write Xc square divided by R square plus 4Xc divided by R plus 3 into Xc divided by R plus this V2 is nothing but this whole term, right? Vf into Xc square divided by R square plus 3Xc divided by R plus 1. So on solving, I'll get Vf divided by Xc cube divided by R cube. If I bring this Xc and R here, 4Xc square divided by R square plus 3Xc divided by R plus Xc square divided by R square plus 3Xc divided by R plus 1. So if I solve, I'll get V out divided by Vf is equal to Xc cube divided by R cube plus 5x square divided by R square plus 6xc divided by R plus 1. Okay. So we know that Xc is equal to 1 divided by Sc, right? So this I can write it as 1 divided by j omega c. So if I can write like this also. Okay. So what is x square? X square is nothing but if I square this term, I will get minus 1 divided by omega square c square, right? What is xc cube? Xc cube is nothing but minus 1 divided by j omega square omega cube c cube. This is nothing but j divided by omega cube c cube. Okay. So you substitute it here. Okay. So what is V naught divided by Vf? V naught divided by Vf is equal to j divided by omega cube c cube r cube plus minus 5 divided by omega square c square r square minus j 6 omega c r plus 1. Okay. So if you equate the imaginary term, you will get the value of frequency. Okay. So equating the imaginary term. So the j term. Okay. So if we take the j term, 1 divided by omega cube c cube r cube minus 6 divided by omega c r, that is equal to 0. So if we equate this whole term to 0, I'll get 1 divided by omega square c square r square is equal to 6. Okay. So what is omega square now? 1 omega square is equal to 6 c square r square. Okay. So if I take the whole root, I will get root of 6 rc. Okay. So what is my frequency? Frequency is equal to 1 divided by 2 pi root 6 rc. Okay. What you are going to do is equating the from this I have equated these two terms, right? So now I'm going to equate the in a real term. So if I equate the real term, I'll get what is V naught by Vf? V naught by Vf is equal to minus 5 divided by omega square c square r square plus 1. Okay. So this is, I'm omitting these two terms, so I'm taking only minus 5 divided by omega square c square r square plus 1. So what is omega square c square r square? It is nothing but 1 by 6, right? So you substitute it here. So you'll get minus 5 into 6 plus 1. So this is nothing but minus 29. So this is nothing but V naught by Vf. What is V naught by Vf? That is nothing but 1 by beta. So my beta is nothing but 1 divided by minus 29. So this minus represent it is having a 180-degree phase shift. Okay. So if beta is 1, we know that according to the Bergerson criteria, the A value is nothing but 1 by beta, that is nothing but minus 29. So you can take the magnitude of this value. So the A value is nothing but 29. Okay.